Okay, guys, we talked about level model, and the picture here at the moment shows you the IEC 62443 model, which is a more simplified structure with a process on level 0 and the enterprise systems on level 4, and in between the industrial automation and control systems. We're gonna have a look on the Purdue model now, which is actually the same, but it just gives you another perspective, a little bit different look on the things, so maybe it is together easier to understand. So let's have a look on the Purdue model, the Purdue Reference Model. It provides a model for enterprise control which end users, integrators, and vendors can share in integrating applications at key layers in the enterprise, and it also helps you for a much better understanding of the whole level concept. Level 0. This defines the actual physical processes. Level 0 is where the actual process equipment that we are controlling and monitoring from the higher levels lives. They are home. Level 0 is where we can find devices such as a motor, pumps, valves, and sensors that measure speed, temperature, or pressure. As level 0 is where the actual process is performed and where the product is made, it is imperative that things run smoothly and uninterrupted. The slightest disruption in a single device can kill all the operations. Level 1 is the place of the intelligent devices. This is sensing and manipulating the physical processes. Process sensors, analyzers, actuators, and related instrumentation. Level 1 is where all the controlling equipment lives. The main purpose of the devices in this level is to open valves, move actuators, start motors, and so on. This does not sound very exciting, but guys, it is important, and this is the main and general function of an industrial control system. Don't forget this. We have to ensure that these things are up and running. Typically found in level 1 are PLCs, variable frequency drives, VFDs, and so-called dedicated proportional integral derivative PID controllers, and so on. Although you could find a PLC in level 2, but its function is more of supervisory nature instead of controlling. So here we have the systems which are really controlling the process and the I/O devices. Level 2, supervising, monitoring, and controlling the physical process. Real-time controls and software, DCS, human-machine interface, HMI, supervisory and data acquisition, the famous PERA software. Many of the functions and systems in level 2 are the same as for level 3, but targeted more towards a smaller part of the area of the overall system. In this level, specific parts of the system are monitored and managed with HMI systems. Think along the lines of a single machine or skid with a touchscreen HMI to start or stop a machine or skid in and see some basic running values and manipulate machine or skid-specific thresholds and set points. Systems typically found in level 2 include HMIs, standalone or system clients, supervisor control systems such as a line control PLC, engineering workstations, and so on. Finally, level 3 is a manufacturing operation system, managing production workflow to produce the desired products, batch management, manufacturing, execution, operations, and management systems, MES and MOMS, laboratory, maintenance, and plant performance management systems, data historians, and related middleware. Level 3 is where systems that support plant-wide control and monitoring functions reside. At this level, the operator is interacting with the overall production systems. Think of centralized control rooms with HMIs and operator terminals that provide an overview of all the systems that run the processes in a plant or facility. The operator uses these HMI systems to perform tasks such as quality control checks, managing uptime, and monitoring alarms, events, and trends. Level 3 site operations is also where the OT systems that report back up to IT systems level 4 live. Systems in lower levels send production data to data collection and aggregation servers in this level, which can then send the data to higher levels or can be queried by systems in higher levels. It's a push versus a pull operation. And systems typically found here in level 3 include database servers, application servers, web and report, file servers, Microsoft domain controllers, HMI servers, engineering workstations, and so on. One thing you must understand, level 3 is for controlling the sub-level 0, 1, and 2. Level 3 is not important for the production at all. If level 3 fails completely, production still can go on without interruption. That's the basic message. Okay, now let's talk about the IDMZ. That's one of the things which are, well, it's a long discussion with many companies and many people inside there. And if you remember, we talked about how to connect a network to a network, and you can start with a simple router. Makes it very simple and easy, not secure. You can add firewalls and you can do different things. The main point here with IDMZ, this is the platinum solution. This is the best and the most secure solution, but you hardly find it in many companies. It is a lot of extra work and it is a lot of design and architecture in here. But on the other side, it is recommended by all the standards and it is recommended by all the experts, and especially if we talk about operators of critical infrastructure, this is a must. All right. The IDMZ is the result of the efforts taken to create security standards such as the NIST Cybersecurity Framework or the NERC-CP. The IDMZ is an information sharing layer between the business or IT systems in level 4 and 5, and the production or OT systems in level 3 and lower. By preventing direct communication between IT and OT systems, and having a broker service in the IDMZ relaying the communications, an extra layer of separation and inspection is added to the overall architecture. Systems in the lower layers are not directly exposed to attacks or compromises. If something were to compromise the system at some point in the IDMZ could be shut down, the compromise could be contained, and production could continue. So systems typically found in this IDMZ or industrial demilitarized zone include web proxy servers, database replication servers, domain controllers, and so on. Let's have a look on some basic rules regarding IDMZ. If you look on the right side, you see the both firewalls, and yes, that's 2 firewalls. And we have one red part. You see common ICT protocols and common ICS, no CIP. That means common office protocols will not be routed down to the industrial security zone, and common ICS protocols like CIP will not route it up to the enterprise zone. There is a big gate and a barrier for all these type of protocols. All network traffic from either side of the DMZ terminates in the IDMZ. Network traffic does not directly traverse the IDMZ. It is the only path between zones. There are no common protocols in each logical firewall. There is no control traffic into the IDMZ. CIP stays home in the industrial security zone. No primary services are permanently housed in the IDMZ. The IDMZ shall not permanently house data. Application data mirror to move data into and out of the industrial zone. There's a limit of outbound connections from the IDMZ, and just be prepared to turn off access via the firewall. It is a switch-off layer. It is definitely a layer you can use for securing the whole lower part. Okay, and finally we have level 4. This is the business logistics systems, managing the business-related activities of the manufacturing operations. And here's ERP, the primary systems. It established the basic plant production schedule, material use, shipping, and inventory levels. Level 4 is home to all the information technology, the IT systems that support the production process in a plant or facility. However, there's a lot of systems, and they are not under control of the plant. These systems report production statistics such as uptime and units produced for corporate systems, and take orders and business data from the corporate systems to be distributed among the operation technology, the OT, or ICS systems. Systems typically found here in level 4 include database servers, application servers, like web report servers, MES, file servers, email clients, and so on and so on. And finally, at level 5, we have the enterprise network. Beside all separation, in a normal company, level 4 and level 5 are the same, so there is no separation between the enterprise network and the so-called site business and logistic planning network. Also, the ERP system mostly stands in the enterprise network. The only separation is if we talk about cloud and internet, then we have another layer. We have we have firewalls inside the enterprise network, which separate the enterprise network from the internet and from cloud services. Well, hopefully they have it. Okay, have a look on this, go to the documentation, and thanks for watching.